we will solve this non-homogeneous differential equation in the matrix form. We will use the variation of parameters method. So first, we should find the homogeneous solution first, and then use the variation of parameters to find the particular solution. At this point, you should know how to do the homogeneous equation, homogeneous solution already. So I just start up with the solution already. And we zoom out, and then we just quickly go through that problem. So we have the eigenvectors, eigenvalues, and then the eigenvectors. Eigenvalues, we're going to solve this characteristic equation, and this is only 2 by 2, so that should be easy. Eigenvectors, we solve this matrix equation, and 2 eigenvalues give us 2 eigenvectors, and we put them in the form of the solution. We should write the homogeneous solution is in that form. Right. One thing to note here, we can stop at the solution for the homogeneous solution like this one, but since we're going to find a particular solution later, so we're going to put that in the fundamental matrix in this form, and we use this for the next part of the problem where we find the particular solution. So that is X, the fundamental matrix. So homogeneous solution, that's how we find a homogeneous solution, and we're going to keep the solution in this form. This is the homogeneous solution. Alright, for the next part where we find a particular solution, we use this fundamental matrix, so we're going to use that for the next part of the problem, the particular solution. Now I just zoom in. Right. Now, particular solution. Will be in the form of X, that the fundamental matrix, just use that, and then the integral of that fundamental matrix inverse times the input function times dt. The input function is given in this case is that. Right. Now first, from the previous page, we have the fundamental matrix 1, 4, negative 4, e to the negative 17t, and e to the negative 17t. Sorry. And that's what we have at the end. Right. Now we're going to find the inverse of the fundamental matrix. The inverse of 2 by 2, I'm going to write very small here. For A, B, C, D, where we're trying to find the inverse of that, it is equal to 1 over AD minus BC. A and D switch places, and B and C change the sign. So that's how we find inverse of a 2 by 2 matrix. So the inverse of the fundamental matrix equal 1 over AD minus BC. This direction minus this direction. And so we have e to the negative 17t minus negative, so that's a plus 16 e to negative 17t. So that will be 17 e to the negative 17t. That is the determinant also. Right. 1 and e to negative 17t swap places, and the other two we negate. That is the inverse. Now we're just going to put in the form of the particular solution. Right, first we have the matrix X, the fundamental matrix. Integral the inverse. We're just going to keep the 17e to the negative 17t like this. E to negative 17t, 4, e to negative 17t, negative 4, 1, multiplied by the input function of t to the negative 1, a plus 4, e to negative t to the negative 1, sorry, dt. Right. And space out a little. Right, so we have one, that matrix I just copy and I do nothing outside of the integral. Integral 1 over 17 e to negative 17t. Right, now we multiply. When we multiply, we use row times column. So this row times this column, and then the second row times the only column. Do that, we will have e to the negative 17t, t to negative 1, plus 32 e to negative 17t, plus 16 e to negative 17t, t to negative 1. Right, so that's the first row. The second row give us negative 4t to negative 1, plus 8 plus 4 t to negative 1. dt. Right, when we simplify, again, outside the integral, we just keep the fundamental matrix X as is. Now we just combine the column, the vector here. Right. So we have 32, and those are the like terms. 1 plus 16 should be 17 e to negative 17t, t to the negative 1, plus 32 e to negative 17t, and then the second row is 8. So combine like terms here, make it 17, and cancel here. Only have 8 left. Again, just keep the fundamental matrix on the outside. Now we multiply that constant inside. We will have on the top, cancel everything. We just have t to negative 1 left. And then plus 32 over 17. The second one, we just have 8 over 17. E to the negative 17 at the bottom, move to the top, it becomes e to the 17t. So we have that. Integrate of that is not too bad. 1 integral of t to -1 is ln of absolute values of t. Let's see on this problem. Yeah, we can assume that t is positive, and then we just have ln of t, but just going to keep like that. 32 over 17t. The second row, we have 8 over 17. Derivative of that is e to the 17t over 17. Right, just a few more steps. And again, I'm going to just copy the fundamental matrix. And then simplify a little bit, ln of t, 32 over 17t, 8 over 17 square is 289, e to 17t. Now when we multiply it out, the first row gives us, again, just row times column. I forgot the plus here. Row times column. First row was first. Now if I multiply this row with that column, and then second row, second column, we have ln of t plus 32 over 17t. That's the first with the first, and then the second one have negative 4 times 8 times 289. That's negative 32 over 289. Now the e to the 17 and e to negative 17 cancel out, and that's all we have, negative 32 over 289. The second, we have 4 times ln of t, absolute values of t, and then 4 times 32, that's 128 over 17t, and then we multiply e to negative 17t and e to 17t. That gives us 8 over 289. Right. So that is the particular solution, and the solution is going to be the combination of the homogeneous solution with the particular solution. So this one is the particular solution. Right, I'll zoom out and look at the whole problem. And that's what we should have. So in this case, if we use the variation of parameters in the matrix form, we're going to use this formula. Usually it's just 2 by 2. If it's 3 by 3, that will be too long for a test question. Because finding the inverse of 3 by 3, that's a little bit of work. So if we use the inverse of 2 by 2, the formula is here, so that's not too bad. Find the inverse and then put in the integral. I'll just keep the dimension of the matrix in the matrix form is clear, and then when we multiply the fundamental matrix X with the result integral, we should have the particular solution. And that's what we have for this problem.